Really excited for this version of Kubernetes Community Days in Bangalore. This is my first time I'm attending this KCD Bangalore. Cool. Let's talk about resource and cost optimization on planet scale Kubernetes clusters. So it is all a Kubernetes day and Kubernetes festival we are talking about. In next 15 minutes we'll try to understand what are the planet scale Kubernetes cluster, the need of optimizing resources, the common scenarios where we can optimize on resources and cost, and the tools used for this optimization, and then later, if time permits, a short question and answer session. A bit about me. Myself, Rahul Mahale. I work at Circle.so as a principal DevOps engineer. It's a community driven platform. That's my Twitter handle and that's my blog link. I'm from Nasik, Maharashtra, and I work remotely with Circle. So when we talk about scale, so the Kubernetes is cool. All the things we can do on Kubernetes are cool. But when running in production, it's both fun and challenging. So anywhere here running a Kubernetes cluster at scale around 1,000 nodes. Anyone here in the room? Okay, 100 node Kubernetes cluster. Cool. More hands. So that's interesting. And running a big cluster is not a huge part, because as of now we have all the automation and Fargate and all the auto scaling in place. But when you are running it for months in production, for years or quarters, you start to notice there are some behavior patterns which are actually increasing your resource utilization, and which turns into the increasing cost as well. So as of now, when we talk about the big clusters, as of the latest Kubernetes version 1.28, we can still spin up around 5,000 node Kubernetes cluster, but I don't think many people do, but there are companies which do have the clusters at that scale, and they are integrated as well. And on one node you can run at max of 110 pods as of now, so 5,000 into 110, that's your pod count you can run on the single cluster. And one pod can have multiple containers as well. Then storage and disk. Whenever you are running your workloads or mission critical applications on Kubernetes cluster, you have storage or stateful sets application which are using storage, and when you have storage into your workloads, there's bit of latency issues, network issues, the utilization issues, and which results into the resource utilization. And Kubernetes as a distributed system gives us a privilege to run multiple services into distributed format. And that's where the beauty of Kubernetes lies. You can run legacy workloads, traditional workloads onto the single cluster, but while running that, you might also encounter some more resource utilization. First thing is, when you start operating Kubernetes cluster in production, we often place autoscaler and think, okay, autoscaler is in place, we are a bit relaxed, and it is going to take care of almost everything of scaling up and down. And it is pre-assumed right now is, if you are using Kubernetes for your workloads, it's going to be smart enough to take care of a lot of things, and that is true as well. But whenever after few quarters or after few billing cycles, you expect that, oh, my cost was supposed to be with allocated budget or below allocated budget, because when we are convincing our leads that while using Kubernetes, that's one of the factor as well, that if you move from another strategies to Kubernetes or containerized strategies, you expect to be the cost on lower side. But in very rare cases that happens, and what is the vice versa situation, that cost actually increases. So we'll see what are the few steps which can help us optimize the resource utilization. First thing is right sizing your resource allocation. When we say resource allocation, when you are deploying any set of pod or container on Kubernetes cluster, you need to make sure that you are allocating good number of CPUs, memories and resources to that pod. And very interesting part is autoscaling, which we deploy on Kubernetes autoscaler. The very famous one is horizontal pod autoscaler, which scales pod horizontally and with number of metrics as well. We can use custom metrics. Then vertical pod autoscaler. So vertical pod autoscaler is also a part of autoscaler, which is mostly used for stateful workloads where we can't scale horizontally, but we can scale vertically. Can we mix both of them? Can we mix both of them, HPA and VPA, for the same resource? Yes, we can mix, but there is a small note on that. When you are using HPA and VPA for the same resource, try to use custom metrics for HPA. Instead of CPU and memory, you can scale it on another resource so that you get the maximum benefit of combining them. Then there is a new tool called as Kubernetes Event Driven Autoscaler, which is more intelligent and it scales based on the events instead of just your hardware metrics. So the kda.sh is very powerful, and if you are using it, it will give you a optimal scaling because it supports various metrics and tools as well. It supports your load balancer metrics, your databases metrics and all, and it integrates it very seamlessly. Then in terms of cluster autoscaler, so above three are a part of application autoscaling. In terms of cluster autoscaler, you have cluster autoscaler, Carpenter and cloud providers autoscaling tools. So cluster autoscaler is here for years. Carpenter is backed by AWS. It's more intelligent and it does more fine and granular fine tuning of scaling cluster up and down, and it's more cloud native. So if you are using cluster autoscaler, that's even fine, but if you are switching to something like Carpenter, that's way better. And with Carpenter, you don't have to really worry because it's a Kubernetes CRD. If you are using something like cluster autoscaler and you are upgrading your Kubernetes versions, you also need to manually check that your cluster autoscaler is compatible with the latest Kubernetes version. Other than that, pod anti-affinity and node affinity, when you are running hundreds of pod across your cluster, they are in microservice fashion. They do talk to each other using Kubernetes service discovery. So at that time, you can check if the same pods can reside on same node group, or if they are talking to different node group in availability zone. You need to take care that they are not really doing lot of cross availability zone traffic that results in increased data transfer cost and also the latency as well. So that one needs to take care. There is a tool called dscheduler. We know scheduler, but there is something called dscheduler. Using that, you can specify that how many number of pods can be scheduled on the particular node. Although it is possible with pod affinity and anti-affinity, but the descheduler also comes into picture when you have a large number of workloads. Then pod disruption budgets. Whenever you are running mission critical applications on Kubernetes while doing blue-green deployments, canary deployments, we do forget about setting up the pod disruption. Pod disruption is nothing but whenever there is a maintenance or there is a change or deployment, how many minimum or maximum number of workloads can be available. So just not forget about mean available replica or max surge. You just have to take care about that, and you should be always be up using that budgets. Then there is zombie. Zombie is nothing but you use it once, but it you forget or to clean it up. So, there are a lot of Kubernetes jobs where you start to for the first time and you just forget about cleaning it up. So you should have a strategy around that, and there are tools for that as well. So efficient pod designing, minimize the number of containers in a pod. If you are running a sidecar container, make sure that it's worth running it. Don't just keep adding the sidecar containers. Then container lifecycle management. With the help of readiness probe, liveness probe, init containers, those are all very efficient if you are having your workloads of the type which are using the scheduled workloads, and also you can use batch jobs, whereas Kubernetes cron jobs or Kubernetes jobs as well. Then do consider putting resource quotas and limits on your namespaces, so that if any of your workload is seeking high resource utilization, it doesn't eats up all your resources on the cloud. Then infrastructure optimization, such as if you are using databases from cloud providers, getting it as in reserved instances, putting them as a savings plan, making them talk on private network using VPCs, using NAT gateways or VPC endpoints, and also monitoring and alerting. We'll not talk a lot about that. There are a lot of people talking about it, but using the right tool for right purpose to monitor and alert you on how it is giving you information about where the resource utilization is happening. And overall, as an cluster administrator or user, you have to continuously optimize and analyze the cluster health and the application utilization. Few of the things while running in production, you can use something like an service mesh to avoid inter-AZ traffic and latency issues. So if you have Elasticsearch or OpenSearch cluster split across 3 nodes in 3 different zones, and it's of 500 GB or 1 TB, the data transfer happens between those Elasticsearch nodes, and that is a cost to your AWS bill. So you can use something like as topology aware routing in Istio, and from Kubernetes version 1.24 there is something called as topology aware hints, which is now a part of EKS as well, where your kubeproxy, if you are using topology aware hints, your kubeproxy will make sure that the request coming from a same availability zone is forwarded to the service which is in same availability zone as well. So that's really important to save latency and traffic across the different region and availability zones. Using VPC endpoints to avoid NAT gateway charges, if you are using object storage like S3 and pushing TBs or GBs of contents, using a single point with private subnets help you over there. Then using IP mode of load balancers, so that if your traffic is directly forwarded to Kubernetes pods, there you save on round trips and obviously on the costs. Then if you are using ingress at scale, ingress is very powerful resource of Kubernetes, and you can use it in conjunction with the certificate managers and provide a lot of custom certificates for SSOs and all. So we were running few of the 1,000 ingresses, and one of the limitation of Kubernetes community ingress is like, if you are creating or updating a existing ingress, it does reload of entire configuration, which causes some performance issues on the fly for the site. So if you want to use lot many ingresses into production, consider using dynamic configuration flag. That was a feature of community edition, but now that has been moved to Nginx Plus. So that is one of the issue in production when you are running ingress at scale. And for clusters with large number of worker nodes, consider using node local cache, so that you don't always make a request to core DNS. Yeah, so we have 1 minute left, so I'll just wrap it up. Then practicing Docker image for the optimization is one of the best practice. You just have to minimize the size of it, use some images like Alpine and all. And for non-production workloads, you can use reserved instances, spot instances, or even a preemptive instances. But having said that, those should be considered for non-production workloads. Also, there are some techniques from cloud providers where we can save costs. So it's just matter of asking our cloud representative, and we can save more there as well. These are few of the tools: KubeCost, Goldilocks from FinOps, then Cloud Zero, OpenCost, and we just had a ML talk. So there are some machine learning tools where you can analyze your infrastructure health and optimize on the resources. So the last thought said by the Peter Drucker: the greatest danger in times of turbulence is not the turbulence itself, but to act with yesterday's logic. When it comes to running production workloads and optimizing it, it has to be it has to come with time and experience. So yeah, any questions?